Hey guys, I'm Smrita Saru and I'm studying in grade 10 in Imperial World School. And today we will be proving that the opposite angles of a cyclic quadrilateral are supplementary, or the sum of opposite angles of a cyclic quadrilateral is 180 degrees. Before we get into that, let's first understand what a cyclic quadrilateral is. Let's take a look at this diagram. Do you know what these white points are? These white points are known as concyclic points. Concyclic points are different from collinear points. Collinear points are the points which are along a straight line. However, concyclic points are the points which are the set of points which lie on the circumference of a circle. As you can see in the figure, there are two circles with different circumferences. The small one and the big one. However, they both have a common center in the middle. This figure can be known as a concentric circle. You may be wondering what a cyclic quadrilateral is. A cyclic quadrilateral is a quadrilateral inside the circle. So right now I'll be showing you what is a cyclic quadrilateral and what is not considered a cyclic quadrilateral. So based on what I had said earlier, do you think this is a cyclic quadrilateral? If your answer was yes, I'm sorry to say, but that was wrong. This is not considered cyclic quadrilateral because the center of the circle is one of the vertices of the quadrilateral. Hence, this is not a cyclic quadrilateral. And then you may be asking yourself if this is considered a cyclic quadrilateral now. This is still not considered a cyclic quadrilateral because one of the vertex of the quadrilateral is beyond the small circle's circumference, which is over here. Hence, this is still not considered a cyclic quadrilateral. So you might be wondering, like, what is exactly a cyclic quadrilateral? Or you may already understand what a cyclic quadrilateral is. This will be a very good example of a cyclic quadrilateral. Four of the vertexes of the quadrilateral is at the concyclic points of the figure of the small circumference. 1, 2, 3, and 4. Hence, this is considered a cyclic quadrilateral. Now that we have understood what a cyclic quadrilateral is, let's move on to proving that the sum of opposite angles of a cyclic quadrilateral is 180 degrees. So we have this figure over here. Do you think this is a cyclic quadrilateral? Yes, this is a cyclic quadrilateral. The four vertexes of the quadrilateral, 1, 2, 3, and 4, they're all touching the circumference of the big circle along the blue line, as you can see. So now let's take the opposite angles of each of the angles. The opposite angle of angle A will be D. No matter how we turn it, the opposite angle of A will still be D. Even if you turn it like this, it will still be D, and like this. So taking angle A and angle D, let's add both of the angles together. As you can see in the figure over here, adding these two angles, we form the shape of a protractor. As you know, a protractor also represents a straight line at the base of it. Hence, this is 180 degrees. So we know that the total sum of angles of a quadrilateral is 360 degrees. So if these two angles sum up to 180 degrees, 360 degrees minus 180 degrees will obviously be 180 degrees. So the sum of B and C must be 180 degrees as well. But let's prove our statement using this diagram as well. So now let's add B and C together. It will form the shape of a protractor. And as you know, it represents a straight line at the bottom, which is 180 degrees. Hence, we have proven that the sum of the opposite angles of a cyclic quadrilateral is 180 degrees, as we can both see over here in this figure. And overlapping them, they still form the same shape. So as we said earlier, the total sum of a quadrilateral is 360 degrees. So we can also prove that using the angles of all sides of the quadrilateral, which forms a circle, and in the center it forms 360 degrees. Thank you very much.